Imagine a message sent from across the stars that arrives before it was ever written. We begin not in a lab or observatory, but in a cold, timeless void, where even light is too slow and causality trembles on the edge of collapse. Somewhere in that void, perhaps, something stirs, not a photon, not a particle we've ever seen, but a whisper of possibility, a tachyon, a creature of theory, a ghost that travels not at the speed of light, but beyond it. And yet, what if that ghost could be bound, not in chains but in quantum entanglement, tethered across vast distances, spinning in lockstep, forever entwined in a dance that Einstein himself called spooky? What if together these two impossibilities formed a bridge, a hidden tunnel beneath the floorboards of reality itself, allowing information to leap across time? This is not science fiction. It is science in its rawest, most dangerous form, a question asked at the limits of understanding. Can entangled tachyons, if they exist, unlock a form of communication that transcends the speed of light? If so, they would upend not just physics, but everything we believe about cause, effect, and the arrow of time. But to understand this forbidden door, we must first return to where it all began, to the moment humanity discovered that the universe was not what it seemed. It began with an experiment, not in the stars but in the atom. A flicker of light, a pair of photons split from a single source. They traveled in opposite directions, yet behaved as if still joined. Measure one, and the other responds instantly, no matter how far apart. No signal passed between them, no time to communicate. And yet the universe rearranged itself to honor their bond. This was entanglement. It wasn't supposed to be possible. According to classical physics, information could travel no faster than light, a cosmic speed limit set by the laws of relativity. But entanglement wasn't sending information in the conventional sense. It was correlation without communication, instantaneous alignment, as if the particles shared a secret before they parted. Einstein didn't like it. He called it an illusion. He believed in hidden variables, that some unseen factor predetermined the outcome. But then came John Bell, with a theorem and later experiments that shattered the illusion. No hidden variables, no secret script, just raw, naked non-locality. But here's the twist. Entanglement can't transmit information, at least not by itself. The moment you try to extract meaning from one half of an entangled pair, the illusion collapses. The other particle reflects the result, but not a message. The universe, it seems, is still keeping its secrets. Or is it? Now imagine this. Instead of photons, what if we entangled tachyons, hypothetical particles that move faster than light? In theory, tachyons have imaginary mass and break the sacred rule of causality. Send a tachyon message, and it might arrive before it was sent. If such particles exist, and no experiment has yet ruled them out, they would live in a different layer of reality, a realm where time loops and paradoxes aren't bugs, but features. What if entangled tachyons could bypass the usual restrictions? What if they could be used to send meaningful information, not by violating the laws of quantum mechanics, but by exploiting them? It's a dangerous question, and it leads us into dangerous territory. Theoretical physicists have long debated the nature of tachyons. Some believe they would lead to instability, that their presence would cause vacuum decay or worse, a complete breakdown of physical laws. Others suggest that they might exist, but be unobservable, hiding behind the curtain of reality, influencing events without revealing themselves. But let's suppose for a moment that they're real, and that we could entangle them. Suddenly, we have a system in which information isn't just correlated across space, but outside of time. You could send a signal backwards, or sideways, or nowhere at all, until the universe is ready to reveal it. Communication wouldn't be linear, it wouldn't follow cause and effect, it would be quantum. This idea has profound implications, not just for physics, but for everything, for free will, for the nature of consciousness, for the question of whether the future already exists, waiting to be received. And it raises a terrifying possibility. If such a communication channel exists, who's to say we haven't already received a message, a thought, a pattern, an intuition that seemed to come from nowhere? What if inspiration itself is entangled? But before we drift too far into philosophy, we must return to the numbers, the math, the razor's edge of quantum theory. Because while tachyons remain hypothetical and entangled information forbidden, the boundaries are not as firm as we once believed. In the coming chapters, we will descend deeper into this abyss. We will examine the paradoxes of faster-than-light particles, the loopholes in Bell's theorem, and the shadowy realm of quantum retrocausality, where the future can affect the past. We'll look at experiments that hint at strange speeds, at time loops, at the possibility that the universe itself might be a kind of network, always connected, always listening. We'll speak with the dead, with Einstein, with Feynman, with the equations they left behind like fingerprints in the dark. And we'll ask, with open eyes and trembling hands, what happens if we build the key and the door opens? Because if the universe has already invented a way to speak across time, we must ask, what has it been saying all along? Next, we turn to the forbidden messenger itself, the tachyon, imaginary mass, infinite speed, and the power to rewrite reality before it even begins. In the realm of physics, there are entities born not from observation, but from necessity. Tachyons are one of them. They did not arise from a telescope or particle detector, but from the mathematics itself, uninvited, inconvenient, and yet persistent. Like a whisper in a dream that refuses to be forgotten, tachyons emerged not as evidence but as possibility, and for decades they've haunted the equations of motion like phantoms in the attic of relativity. To understand tachyons is to confront a paradox at the heart of our universe, the nature of speed, and the boundary between what is allowed and what is forbidden. According to Einstein's special relativity, nothing with mass can reach the speed of light. As you accelerate a particle closer to light speed, its mass, and the energy required to move it, grows toward infinity. Light itself moves at this limit only because it is massless. The universe, it seems, has locked its doors tight. But the mathematics offers a strange mirror image. If we imagine a particle that always travels faster than light, one that never slows to subluminal speeds, the equations still work. But only if that particle's mass is not a real number, but an imaginary one. Not imaginary in the sense of fantasy, but in the mathematical sense, a number multiplied by the square root of -1. This is the tachyon, a hypothetical particle that defies everything we know about matter, time, and causality. In theory, a tachyon would slow down as it gains energy, the opposite of ordinary particles. As it loses energy, it speeds up. It cannot be caught, only glimpsed in the limits of imagination. And worse, it might allow messages to be sent backwards in time. Imagine a gun that fires a tachyon message into the past. The receiver picks it up before the trigger is even pulled. Cause and effect unravel. Paradoxes bloom. Could you send a warning to yourself to not fire the gun? What happens then? These are not idle thought experiments. They are razor-edged puzzles that slice into the foundations of logic itself. Because tachyons don't just violate our understanding of speed, they threaten the integrity of time. And yet, they haven't been ruled out. No experiment has confirmed their existence. But none has conclusively disproven them either. In some quantum field theories, tachyonic fields appear and are then stabilized away. In others, they're signs of instability, a system on the verge of transformation. The term tachyon has become a placeholder, a signal that something deeper lurks beneath the surface. So, why do physicists still whisper their name? Because perhaps they offer answers to questions that no other particle can. Dark energy, vacuum instability, the early inflation of the universe. Even the strings of string theory have flirted with tachyonic modes, as if the universe itself contains structures that briefly flirt with impossibility, then collapse into order. But if tachyons do exist, not as fields but as particles, what would that mean? It would mean the cosmic speed limit isn't absolute, that the universe has layers we have yet to touch. That information might flow across a higher topology of space-time, not a straight line, but a folded sheet. In such a geometry, the shortest path between 2 points might not be a line at all. Could tachyons inhabit this hidden layer? Could they slip between folds, bypassing the rules we call fundamental? More provocatively, could they carry entanglement with them? In ordinary quantum mechanics, entangled particles behave as if linked instantaneously, but no information passes between them, at least not in any measurable way. It is coordination without communication. If tachyons exist, could they serve as a carrier wave, transforming correlation into communication? The challenge is immense. First, we would have to detect a tachyon. But how do you measure something that moves faster than your tools can see? A particle that outpaces its own cause? Some have proposed that tachyons, if they exist, would appear as anomalies, energy discrepancies in particle collisions, or unexplained phase shifts. Others have speculated that the neutrino, the ghost particle of the Standard Model, might be tachyonic. At one time, measurements hinted it might have an imaginary mass. Those measurements were later corrected. But the mystery lingered. Perhaps the tachyon is not a thing to be found, but a thing to be understood. Like the horizon of a black hole, it might define the boundary of knowledge, the place where our laws stop working and something stranger begins. And perhaps that's why the idea persists, not because it is proven, but because it is needed. If entangled tachyons could exist, they would occupy a unique niche, part quantum, part relativistic, part myth. They would move faster than light, but not as messengers of noise, as messengers of meaning. They could be the missing puzzle piece that turns quantum entanglement from eerie coincidence into usable communication. But if so, why haven't we seen them? That question may be the most important of all. Because some answers aren't hidden, they're simply out of reach. Beyond the event horizon of our tools, our thoughts, even our language. The tachyon may be one such answer, forever visible in the math, yet invisible in the world. A creature born of symmetry and exile, and yet, like a siren in the mist, it calls to us. Because if faster-than-light messaging is possible, even in theory, then everything changes. Not just our physics, but our future, our concept of privacy, of choice, of time itself. And it forces us to confront a terrifying question. If messages can be sent into the past, then who is sending them? Next, we step into the shadows of quantum entanglement itself, the thread that binds the universe instantaneously across the void. What happens when it meets a messenger that runs faster than time? We're about to find out. Across the silence of the cosmos, something stirs, not with sound, but with symmetry. Two particles, born together, separated by light years, still somehow aware of each other. No signal, no delay. Just a change, and a mirror change, as if the universe were completing a sentence written in two different places at once. This is quantum entanglement, the binding thread, a phenomenon so strange that even Einstein refused to believe it. He called it spooky action at a distance, not because it was wrong, but because it was deeply, maddeningly right, in all the ways our instincts say it shouldn't be. And yet, the experiments leave no room for doubt. We have split particles. We have measured their spins, polarizations, momenta, and again we find them entangled, perfectly correlated, regardless of how far apart they travel. Tinker with one, and the other reflects the change instantly, as if the fabric of space itself were bypassed. But here's the crucial twist. The thread cannot carry a message. This is the great cruelty of entanglement. It can share a state but not a signal. You cannot choose the outcome of your measurement. You can only observe. The entanglement persists, but it cannot be used to transmit information faster than light. Unless we've misunderstood something. Unless there is a second thread, invisible, faster than light, and waiting. To understand the depth of entanglement's mystery, we must look at the core, the wave function. A probability cloud, not a definite truth. It only collapses when observed. Until then, it is all things, both up and down, both 0 and 1, and when two particles are entangled, their wave functions become entwined. They do not possess separate realities. They share one. Separate them by a millimeter or a million kilometers. It makes no difference. The moment one is measured, the other reacts. Not in the future, not in the past, instantly. This is non-locality, the horror and beauty of quantum mechanics. A hint that space, as we understand it, may be an illusion, a convenience. That distance is not fundamental. What is fundamental then? What ties these particles together? Some physicists suggest that entanglement is not a feature of space, but the very thing from which space emerges, that the geometry of space-time may be woven from these invisible threads. If true, entanglement is not just weird, it's everything. But then, why can't we use it to send messages? The answer lies in the randomness of quantum measurement. When you observe your half of the entangled pair, the outcome is unpredictable. You cannot control whether it's spin up or spin down, and so you cannot encode information. But what if something else could? What if, instead of ordinary particles, we entangled tachyons, entities not bound by light speed, not bound by time as we know it? Could their entanglement behave differently? Could they somehow bypass the randomness, not to change the outcome, but to deliver a pattern? Imagine two entangled tachyons, one on Earth, one in orbit. As one is measured, the other responds, not just instantaneously, but before. The response arrives first, the question follows, a causality loop, a closed temporal circuit, and suddenly the impossible becomes thinkable. We've already seen that entanglement defies distance. Could tachyons, theoretical carriers of faster-than-light motion, defy the informational barrier? It wouldn't be traditional signaling. It would be something stranger, a modulation of entanglement itself, a way of biasing probabilities through subtle influence. Not a letter sent, but a nudge, a weighted coin that lands heads more often than chance would allow. Is this possible? According to mainstream quantum mechanics, no. Entanglement is protected by the no communication theorem. But if tachyons exist, and if they can be entangled, the rules might change. The no communication theorem is built on assumptions that signals can't travel faster than light, that particles obey locality, that time flows forward. Tachyons tear those assumptions apart. Some physicists have even speculated about entanglement-assisted tachyonic signaling, a layered system where entanglement establishes correlation and tachyons inject bias. Together they might bypass the wall between randomness and meaning, but it comes at a cost. Because once you allow information to flow faster than light, once you allow effects to precede causes, the universe begins to fracture. You open the door to causality violation, messages sent into the past, loops of information with no origin, paradoxes that devour logic. And yet, the mathematics holds. Relativity allows faster-than-light particles if they always stay beyond the light barrier. Quantum theory allows entanglement if no usable signal is extracted. But what happens when you fuse the two? What happens when a forbidden messenger binds itself to a forbidden thread? Perhaps reality unravels, but perhaps a new reality emerges. One in which time is not a line but a web. One in which communication is not sequential but entangled across timelines, where the future sends messages to the past, not in words, but in waves. What might we say to ourselves? And would we listen? Already, experiments at the frontier of quantum information are nudging the edges of what is allowed. Loopholes are being closed. New techniques in delayed choice, entanglement swapping, and quantum teleportation are pushing us closer to understanding how and whether entanglement can ever be made practical. None have crossed the line into faster-than-light signaling. Not yet, but the pressure is mounting, the questions are multiplying, and the tachyon waits, like a blank space in the laws of physics, daring us to fill it. Because if the binding thread can be tied to a faster-than-light courier, then the map of reality must be redrawn. And if that happens, we must ask who or what draws first. Next, we enter the eye of the storm, the paradox at the center of this inquiry. What happens when information loops back on itself? What happens when the future touches the past? We step now into the domain of quantum retrocausality, and everything we thought we understood about time is about to fall away. Time, we are told, moves forward. From past to present, present to future. A river with one direction and no return. But what if that's not true? What if the river bends? What if, beneath the surface of time, there are currents that run backward, subtle, silent, invisible, but real? This is not the realm of fiction, it is the terrain of physics at its most radical, most unsettling. A realm called retrocausality, the idea that the future can affect the past, that what will happen can influence what has. And if such a thing is possible, then the door to faster-than-light communication doesn't just open, it reverses. Because what is faster-than-light travel, if not a shortcut through time? And what are tachyons, if not messengers that arrive before they are sent? For decades, physicists have grappled with this paradox. Entanglement suggests an instant connection across space. Tachyons suggest superluminal motion, and retrocausality suggests that time itself may be nonlinear. It begins, like many quantum mysteries, with a simple experiment, the delayed choice quantum eraser. Fire a photon toward a screen. It can go through two slits. With both slits open, it creates an interference pattern, the signature of a wave. But add detectors to determine which slit it passed through and the interference vanishes. The photon behaves like a particle. One path, one choice. But here's the twist. If you delay the decision to observe which path the photon took, if you choose to erase or preserve the which path information after the photon has hit the screen, the pattern still responds. It's as if the photon knew what you were going to do, as if your future choice changed its past behavior. This isn't metaphor, it's measurement, repeated, verified. And it has forced physicists to question the most basic assumption of causality. Some interpret it as a quantum illusion, a quirk of statistics. Others, like Yakir Aharonov and proponents of the two-state vector formalism, propose something deeper, that quantum systems are defined not only by their past, but by their future, that a particle's state is shaped both by the conditions of its creation and the conditions of its measurement, past and future converging on the present. It's as if reality itself is formed not by a single stroke of time, but by a handshake across the ages. And if that's true, then entangled tachyons, particles that already defy time's flow, might not just be messengers. They might be participants in this handshake. They might carry information not only across space, but across time. Consider this. If a tachyon can be entangled, and if its entanglement can be influenced by a future measurement, then we could, in principle, create a feedback loop. A system where future choices shape past outcomes, and those outcomes shape future choices in return. A quantum time loop, a message sent backward not by brute force, but by quantum grace. But this isn't just academic. It has consequences, because if the future can influence the past, then the past is not fixed. And if the past is not fixed, then memory becomes suspect, choice becomes suspect, self becomes suspect. How do you navigate a world where your actions might be determined by events that haven't happened yet? And deeper still, who or what is orchestrating the sequence? Is it randomness, probability, or is there someone curating the flow? Physicist John Cramer proposed the transactional interpretation of quantum mechanics, a model in which quantum events involve both a wave traveling forward in time and a confirmation wave traveling backward. Only when the two meet does an event become real. A particle is not emitted and then received. It is agreed upon across time. Such a model reframes communication entirely. It's no longer about sending. It's about convergence, about matching signals from past and future until the universe allows the event to occur. Now imagine this with tachyons, not particles passively awaiting measurement, but active agents in a bidirectional network, signals bouncing between potential futures and probable pasts, aligning, amplifying, collapsing into meaning. Could this be the mechanism by which faster-than-light messaging occurs, not by brute transmission, but by quantum negotiation? If so, the implications are enormous. We would no longer live in a causally closed universe. The future would not just be unknown. It would be in play, influenceable, reachable, perhaps even writable. It would mean that intention, that very human act of aiming at a future, might have more than symbolic power. That thought, focused and entangled, could resonate across the temporal spectrum. But it also means danger, because if we can send information backward even subtly, then the potential for paradox becomes overwhelming. Imagine receiving a warning from the future, "Don't build the machine." But by receiving that message, you choose not to build it. So the warning was never sent. But then you do build it. The loop reopens, the message returns. This is the grandfather paradox, where cause and effect collapse into contradiction. Some theorists propose solutions. Novikov's self-consistency principle, for instance, argues that the universe prevents paradoxes. That any time loop must be self-consistent, events can influence the past, but only in ways that do not create logical contradictions. But this raises a more disturbing question. If true, it would mean that your choices are not entirely free, that your actions are constrained by consistency, by the demand that the timeline remain intact. And so we are faced with a terrifying possibility. If faster-than-light communication is possible through entangled tachyons or retrocausal loops, then free will itself may be an illusion. You may be acting not as an independent agent, but as part of a quantum feedback system, your decisions guided, nudged, required by events yet to occur, and yet you feel free. Because the loop is closed, the signal is subtle, the causality circular. So the question becomes, not just can we communicate faster than light, but have we? Have we already received messages from the future, dreams, insights, warnings, and mistaken them for imagination? In the next chapter, we will examine the experimental edge, the strange data, the hints in particle accelerators, cosmic rays, and deep space phenomena that suggest something may already be leaking through the light barrier. Because if the future has been reaching back, it may have left fingerprints. And we're just beginning to see them. If faster-than-light particles exist, where are they? If the future can speak to the past, why don't we hear it? These are the questions that critics rightly ask. They demand evidence, hard data, signals, traces, something beyond theory. And perhaps they already exist, not in bold announcements or obvious detections, but in whispers, inconsistencies, anomalies, shadow signatures hidden at the edge of our instruments. Perhaps the universe has been leaking its secrets all along, and we simply haven't known how to listen. Let us begin with the cosmic rain. Every second, Earth is bombarded by particles from space, cosmic rays hurled across the galaxy by dying stars, black holes, and unknown forces. Most are ordinary, protons, electrons, atomic nuclei. But some are not. Some arrive with impossible energies. The most energetic cosmic rays ever recorded, like the famed "Oh my God" particle, slam into our atmosphere with more force than any particle accelerator on Earth could produce. The source? Unknown. The explanation? Incomplete. Some physicists have asked, how did a particle travel such vast distances without losing energy? Could it have moved outside space-time? Could it have been tachyonic, briefly dipping beneath the speed of light radar, then re-emerging? We can't prove it, but the math doesn't rule it out. Then there are the neutrinos, the ghost particles. Trillions pass through your body every second. Massless for decades, they were eventually found to have a tiny, but real, mass. But for a brief moment in the early 2000s, something strange happened. A team measuring neutrino velocities at the Opera experiment in Italy reported a startling result: neutrinos arriving faster than light. It was headline news. If true, it would overturn relativity, a Nobel Prize guaranteed. But within weeks, the anomaly was retracted. The cause? A faulty cable, a timing error. The physics community breathed a sigh of relief. But the incident raised a possibility that many had quietly wondered. What if tachyons exist in a form we're already observing, but misinterpreting? Neutrinos are elusive, barely detectable. Their behavior often brushes the limits of our certainty, and if even one flavor of neutrino turned out to be tachyonic, traveling just outside the normal time-space continuum, we would have to rewrite the rules. Then there is the tachyonic field hypothesis. In certain quantum field theories, especially within string theory, tachyon fields appear not as particles, but as signals of instability. These are not messengers, they are warnings. When a tachyonic field emerges, it means the current state of the system is unstable, ready to decay into something more stable. But here's the twist. This process can release energy. It can reshape reality. Some have proposed that the inflationary epoch of the early universe, the rapid expansion moments after the Big Bang, was triggered by a tachyonic-like instability. If true, then the birth of the cosmos itself may have been sparked by a tachyonic phase transition, a faster-than-light expansion driven by a field that should not exist, but did. And yet, the evidence remains indirect, a shimmer, a shadow. But there is one more place to look: the data itself. In recent years, artificial intelligence has begun combing through particle physics datasets, not just to find known patterns, but to uncover unknown unknowns, anomalies, deviations, things that do not fit. And in some corners it has found them, energy signatures that shouldn't exist, event pairings that defy locality, statistical clusters too consistent to be noise, too strange to explain. Are these signs of tachyons, of entanglement across time? Or are they simply the noise of a universe more complex than we imagined? Perhaps the problem isn't that the evidence is missing. Perhaps it's that we're looking in the wrong direction. We assume tachyons, if they exist, would behave like ordinary particles, emit radiation, leave trails, appear on our screens. But what if they don't? What if they flicker through our reality, leaving only probabilistic fingerprints, shifting the odds in quantum outcomes, appearing not as hits on detectors, but as subtle biases in entangled states? Imagine this. An experiment measuring entangled particles finds a slight, but consistent, skew in outcomes. A deviation too small to trigger alarms, but too persistent to ignore. Not enough to violate the no communication theorem, but enough to hint that something is leaning on the scales. Could this be a tachyonic influence? Could these tiny anomalies be messages, encoded not in bits or pulses but in probability itself? It would be the perfect disguise, a signal hidden in randomness, a code that only becomes visible when observed across time, at scale with purpose. But here lies the dilemma. Science is built on falsifiability, on measurable predictions, and tachyons by their very nature evade those terms. They live beyond the measurable, beyond light, beyond testability, unless We find a way to entangle them. This is the keystone of our hypothesis. If we can entangle tachyons, if we can manipulate them indirectly through interactions with standard particles, we may be able to craft experiments that detect their presence by proxy. Correlated shifts, unusual delays, reversed influence patterns. In the years to come, quantum computers, entangled networks, and precision detectors may give us the tools to test these fringes, to look not for the particle itself, but for the footprints it leaves in the quantum field. And if we find them, then the shadows will part, and the line between past and future will blur. Next, we explore the architecture of such a discovery. How might we design a system, a bridge, between ordinary entangled particles and faster-than-light channels? Could it already exist in nature, in the fabric of space-time? Because if the evidence is hiding in the shadows, it may be time to bring the shadows into the light. If entangled tachyons are the key, then what does the lock look like? What would it take, not in theory but in architecture, to build a bridge between two impossible realms, quantum entanglement and faster-than-light transmission? It begins not with machinery but with understanding, that peculiar kind of engineering that happens in the dark when physics begins to smell like philosophy. Entanglement is delicate. Tachyons are hypothetical. But if they can meet, if they can interface even by proxy, then the structure that allows that meeting is not a laboratory, but a channel. So we must ask, what defines a quantum communication channel? What makes it stable? What makes it meaningful? And then we must ask, what if it's not a channel at all, but a loop? To build this bridge, we must first navigate the terrain between classical causality and quantum uncertainty. Information in our world has rules. It must travel from sender to receiver within time's forward march, bound by the speed of light. But entanglement feels different. It's not about sending, it's about sharing, as if two particles, however distant, hold fragments of a single truth. Now add tachyons to this equation, particles that, if real, exist entirely on the other side of the light barrier. They cannot be slowed to our speed. They cannot be paused or observed like photons or electrons. They are motion. They are the signal already past its destination. So how do we connect them? How do we build a tunnel between the shared state of entanglement and the unstoppable momentum of tachyonic propagation? There are three speculative architectures that physicists and theorists alike have imagined, each more daring than the last. The first is quantum proxy coupling. In this model, we don't interact with tachyons directly. We use intermediaries. If tachyons can influence certain quantum fields, say those of neutrinos or hypothetical scalar fields, then entangling those standard particles might allow the influence of a tachyon to bleed through. Not a message, but a modulation. Like the pull of gravity on the skin of water. We don't talk to the tachyons. We watch how entangled systems change when exposed to tachyonic influence. It's subtle, it's messy, but it's testable. The second model is more radical, quantum tachyonic resonance. Here the idea is that entanglement might create a kind of standing wave, a space-time resonance pattern, that under very specific conditions could amplify the effect of a tachyonic interaction. Like the strings of a violin vibrating in sympathy with sound, entangled particles might resonate with tachyonic fields, creating brief, coherent bursts of correlated faster-than-light influence. Not noise, not chaos, but signal. Weak, fleeting, but real. This approach suggests the possibility of a laboratory interface, an engineered entanglement array held in supercooled vacuum, sensitive to fluctuations in boundary conditions, Casimir forces, quantum foam jitter, vacuum polarization, a whispering gallery of the quantum realm. But there is a third model, the most speculative and perhaps the most terrifying. It is the entropic loopback system. In this model, the key is feedback, a closed quantum system in which outcomes are selected not only by forward-flowing decoherence, but by constraints imposed from the future. In essence, the experiment is designed to allow retrocausal closure. You set up an entangled system, you prepare both ends, you allow for measurements, but only under conditions that would result in self-consistent loops. If the result would create a paradox, the system collapses differently. If the result would preserve causality, even in a nonlinear form, the outcome stabilizes, and so information flows backward, but only in ways that complete the circle, like a river that knows how to loop without ever flooding its banks. It is no longer communication in the human sense. There is no sender, no receiver. There is only constraint, self-consistency, and the eerie suggestion that the future already knows what the past must become. Could such a system be built? Some say it already is. Nature may have embedded these loops in the structure of reality itself, in entangled states shaped not just by initial conditions, but by final ones as well. Like stones in a stream, future measurements may already be guiding present probabilities. We call it randomness. But what if it's guidance? Imagine this architecture applied to communication, not a message you send, but a result you arrange, a detector set to pick up patterns. You don't control the exact bits, but over time, over millions of entangled events, a bias emerges. A pattern shaped by a future observer who knows what to look for. The bridge, then, is not a wire. It is a coordinated collapse of uncertainty, a pressure applied from both ends of time, not to push information through, but to allow it to fall into place. Like stones skipping across water from both directions at once. This kind of system would not look like a transmitter. It would look like a trap for meaning, an elaborate net strung across timelines, waiting for the right combination of quantum events to flicker into place. You would need precision, patience, and perhaps permission. Because what emerges from this model is not just faster than light communication, it is consensual causality, a timeline that agrees with itself, past and future alike. You cannot send a paradox through such a system. You can only send that which already fits. And so we return to our central thesis. If entangled tachyons exist, they may not behave as signals, they may behave as anchors, cross-temporal stabilizers, keys not to faster messaging but to meaningful alignment. The message, then, is not what you transmit. The message is what you become when the loop closes. Next, we must confront the enemy of all this wonder, the guardian of order, the enforcer of limits, causality. What happens to our world when the chain of cause and effect breaks? What rises in its place? Because if this bridge is built, we must know what we are crossing into. Causality, the sacred thread that binds our universe together. The reason we trust that a cup falls after we drop it, that thunder follows lightning, that death comes after life, not before. It is so deeply embedded in our perception that we rarely question it. Cause and effect, action and reaction. One leads, the other follows. Always unbreakable until now. Because when you introduce tachyons into the equation, when you mix faster-than-light particles with quantum entanglement, that thread begins to fray. And in the silence of that unraveling, a new kind of physics begins to whisper. To see how fragile causality truly is, consider this. The very foundation of special relativity is built upon the idea that nothing can travel faster than light. This is not an arbitrary rule. It's a guardrail, a firewall that prevents one event from affecting another outside its light cone, the region of space-time that can be causally connected. Tachyons, by their very nature, break this rule. They exist outside the light cone. They can connect events that, by all logic, should be causally disconnected. A signal sent with a tachyon can arrive before it was sent, in another frame of reference. Time becomes slippery. Cause becomes effect, and effect becomes origin. Physicists call this the tachyonic anti-telephone, a thought experiment in which two observers, each moving relative to the other, use tachyons to send messages into each other's past. Set up correctly, this leads to a loop where a message prevents its own transmission, a paradox, a breakdown, a causality collapse. At first glance, it seems absurd. Nature shouldn't allow it, and yet, mathematically, it works. There is no inconsistency in the equations. The problem isn't the math, the problem is us, our insistence that time flows in one direction, and that's where quantum mechanics steps in. Quantum systems already flirt with the edges of causality. Entangled particles react instantaneously across space. The outcome of a measurement here affects the state of a particle there. No signal, no time lag, just a global readjustment of reality. And yet somehow, the universe keeps causality intact. No information is transmitted. No paradox arises. But what if it did? What if, through a bridge of entangled tachyons, information could be sent back? Would the universe prevent paradox, or would it simply adapt? This is the heart of the Novikov self-consistency principle, the idea that any event that would create a paradox is simply forbidden. That time, when looped, only allows loops that are internally consistent. It's elegant, it's tidy, but it's also deeply unsettling, because it implies that we do not have absolute freedom, that even when the future reaches back and touches the past, it does so along predetermined paths, possibilities that already fit within the puzzle. In this view, faster-than-light communication doesn't unlock chaos, it reveals constraint. The signal you send to your past is the signal you must have sent. The warning you receive is the one you were always going to hear. The loop closes cleanly. No contradiction, just fate, wearing the costume of physics. But there are darker interpretations. Some theorists argue that causality, once breached, does not collapse neatly. It fractures, spawning divergent timelines, parallel realities, quantum forks. The moment you change your past, you create a new future, a branching universe in which the message is sent, but its consequences unfold along a separate track. This is the many worlds interpretation, not just of quantum mechanics, but of time itself. In this view, every act of tachyonic messaging is a cut through the fabric of a single reality, a doorway into another. The sender and receiver are no longer bound by a shared fate. They become explorers of possibility, wanderers in a sea of timelines. But even here, causality is not dead. It is merely distributed, spread across multiverses, upheld locally, sacrificed globally. So where does that leave us? If entangled tachyons exist, and if they can transmit information, then causality cannot remain untouched. Something must give. Either 1. The universe self-corrects, allowing only paradox-free loops. 2. It fractures into parallel branches, each preserving causality locally. 3. Or it surrenders causality altogether and embraces a reality where the future and the past are locked in mutual recursive influence. And here's the haunting part. In all three models, you can't tell the difference. To the observer, to us, reality still feels sequential. Memories still feel stable. Events still appear to unfold in order. Even if messages are being passed across time, even if choices are being shaped by the future, we cannot see the causality break. It's hidden, folded inside the structure of the loop, like an echo that causes its own sound, or a message received that inspires its own writing. This is the illusion of free will in a causality-compromised universe. We act, we choose. But perhaps only within paths that were always going to occur, consistent paths, entropic minima, reinforced through quantum pressure. And so the collapse is not violent, not dramatic. It is silent, invisible. A causality that no longer rules, but negotiates. One that allows just enough freedom for wonder and just enough structure to prevent collapse. But how would we know? How would we detect such a subtle, recursive universe? In the next chapter, we explore this question head-on. We dive into experimental models that might catch causality in the act, feedback systems, signal delay loops, and time-symmetric experiments designed not to break physics, but to reveal its deeper layers. Because if causality has already collapsed, gently, invisibly, then the evidence must be here, hidden in the timing of the world itself. If the future can influence the past, and if causality has been compromised, even slightly, then something extraordinary must follow. There should be evidence, not in the form of grand paradoxes or reversed explosions, but in glitches, slips, moments when time doesn't quite behave, anomalies that don't scream but whisper, patterns that seem to anticipate themselves, a signal that knows it's coming. And if such moments exist, then we must design machines not to force the loop open, but to catch it closing. Let us begin with a deceptively simple idea, a feedback circuit between quantum states and classical outcomes. Imagine a system built around entangled particles, say photons or electrons, where the choice of measurement basis is determined by the outcome of a prior entanglement event. But here's the twist. The system is closed. Each measurement determines the setting for the next, in a recursive loop. The logic cycles. Now introduce a delay, a gap between detection and decision. Not much, a few microseconds. Long enough for quantum indeterminacy to evolve. Short enough to allow the circuit to behave as if the future is informing the present. This is called a delayed choice entangled feedback loop. It's real, it's been built, and its implications are profound. Because in some configurations, the output suggests correlations that appear before their causes. The pattern emerges before the trigger is pulled. The choice seems to ripple backward, and the more we refine these systems, the stranger they behave. Another example, the quantum random number influence test. In this setup, a quantum random number generator is allowed to run freely, producing an unpredictable sequence. Later, perhaps hours or days, a completely independent system is set to react to one of those numbers. The reaction is random, but statistically, patterns emerge. The earlier numbers, supposedly random, show a bias, as if they were subtly influenced by the later event. Skeptics call it noise, coincidence, but the correlations persist. Across labs, across continents. Some researchers even claim that human intention, focused thought, can bias quantum randomness after the fact. This is the foundation of the Global Consciousness Project, where random number generators placed around the world seem to deviate from pure entropy during moments of global emotional intensity, terrorist attacks, New Year's Eve, the death of world leaders. But set aside the mysticism, strip it down to physics. What's being tested, what's being provoked, is this. Can a system's future state constrain its present evolution? And if so, is it local, is it quantum, or is it tachyonic? Because here's where things get stranger. Some proposed experimental models allow for retrocausal interference, the kind of influence you'd expect if tachyons were interacting with entangled systems. In these setups, you perform a standard entanglement experiment, but you insert a switch, a choice made after entanglement has occurred, that affects whether interference is visible. You're not sending a signal, you're adjusting a boundary condition. And in some versions, the interference appears or disappears depending on that delayed choice, retroactively. It's as if the system reaches forward, samples the future condition, and decides how to behave. A causality loop, a handshake with tomorrow. But these effects are tiny, subtle, difficult to repeat. The noise is immense, the skeptics are loud, and the evidence is inconvenient. Still, the loops persist, so how might we catch them more clearly? Here's one speculative design, the quantum tachyon transduction trap. You begin with an entangled system, photons, neutrinos, or superconducting qubits. You arrange them in such a way that any deviation from standard quantum behavior, any leakage of information, is recorded with picosecond precision. Then, you introduce a hypothetical tachyon channel, perhaps a medium designed to host field instabilities that could support superluminal fluctuations. Think Casimir cavities, engineered vacuum fluctuations, or quantum field resonators. Then you run the system millions of times, not looking for direct communication, but for statistical drift. Small shifts in correlation that exceed quantum bounds. Patterns that suggest one side of the system is anticipating the other's measurement choice across time. It's not a message, it's a nudge. But if it repeats, you have the loop. Not proof of tachyons, not proof of time travel, but proof that information may be bleeding across boundaries we thought were impassable. And perhaps that's all we'll ever get. Because if the universe enforces self-consistency, if it demands that causality loops be subtle, stable, and hidden, then we may never see the loop open. Only the evidence that it has already closed. The results won't be dramatic, they'll be mathematical, probabilistic, but undeniable. A slight tilt in the balance of outcomes, a ghost fingerprint, a message that arrives not in words, but in probability. And if that's how the future speaks, then we must learn to listen differently, not for loud announcements, but for symmetries that shouldn't be there, for correlations too perfect, for events that seem pre-selected, as if destiny had a script and physics was following its cues. And this leads to the final terrifying implication. If we can catch the loop in action, if we can detect even the whisper of retrocausal entanglement, then someone, or something, could be using it. Right now. In the next chapter, we'll dive into this possibility that messages may already be moving backward through time, encoded not in voice or code, but in shifts of probability, in dreams, in discoveries, in coincidences too elegant to ignore. Because if the loop is real, then we must ask not just how it works, but who is listening. What if you've already heard from the future? Not in words, not in sound, but in a subtle pull, an idea that arrives unbidden, a dream that lingers like a memory of something not yet lived, a choice that felt guided by something beyond reason. We dismiss these moments, coincidence, intuition, randomness. But what if they're not? What if they're messages, encoded in the only language the future is allowed to speak? Probability. In a universe where causality is soft, where entangled tachyons ripple across the seams of time, communication would not be direct. It would be statistical, not a voice from the future, but a tilt, a shift in odds, a weighting of one outcome over another, like a loaded die that favors meaning. And once you begin to listen in this way, the world starts to sound different. Because if entangled tachyons do exist, if they can subtly modulate entangled systems, then their messages would arrive not through sound waves or radio signals, but through patterns, nudges, unlikely alignments, whispers in the data. Imagine a researcher, up late, struggling with a problem. The answer arrives suddenly, not logically, but fully formed. A flash of insight, a gut feeling, a knowing. He calls it a eureka moment. But what if that moment was not an act of brilliance, but a response, a completion of a loop, a message sent backward from the solution he would eventually discover? Now multiply that by 1,000, 1,000,000. History becomes littered with these moments, technological leaps that arrive too early, artistic movements that seem to anticipate the future, equations discovered before their practical use was even conceivable. Is this just genius? Or are we tapping into something deeper, a signal embedded in space-time itself? The future, after all, is not blank. It is a tapestry of probabilities. And perhaps among those probabilities, the act of becoming is itself a kind of feedback, a loop where the act of observing the future reshapes the present and vice versa. This is not mysticism, it is quantum logic, reframed. In quantum mechanics, every particle exists in a state of potentiality until it is measured. But what if that measurement is not just anchored in the past? What if it's also influenced by the future state of the system, not determined but guided? This idea is explored in interpretations like the two-state vector formalism, where a quantum system is defined not by a single wave function moving forward in time, but by two, one evolving from the past and another collapsing backward from the future. The reality you observe is the meeting point of those two waves, a handshake across time. Now apply that to information. If a future outcome can constrain present probabilities, then intentional influence becomes possible, not through force but through selection. Imagine an artificial intelligence trained to identify subtle shifts in entangled systems. Over millions of iterations, it begins to recognize anomalies, patterns that suggest information is leaking through the system. Not in binary, but in statistical drift. The AI learns to ask questions not by waiting for answers, but by observing how the universe tilts in response. This is where messaging begins, not with a transmitter, but with a receiver. A consciousness, human or artificial, sensitive enough to detect when the noise begins to sing. This has already been imagined, albeit in fiction, in Ted Chiang's Story of Your Life, later adapted into the film Arrival. A linguist begins to understand an alien language that encodes thought non-linearly. As she learns the language, she begins to think non-linearly, to perceive her life not as a sequence of moments, but as a whole, past, present, and future coexisting. This isn't just science fiction, it's an allegory for temporal entanglement. The idea that information, once embedded in the structure of the universe, can be accessed from either direction. And if consciousness, or a sufficiently advanced system, can become attuned to those directional flows, then the act of receiving messages from the future may already be underway. The real question is, what are we being told? If a future civilization discovered how to send messages backward, would they risk paradox? Would they shout their warnings through time? No. They would whisper. They would embed signals in evolutionarily stable strategies, in math, in symmetry, in curiosity itself. They would create attractors, ideas that pull minds toward discovery, nudging our civilization ever so slightly toward the path where the loop closes. They would not tell us what to do. They would shape what we want to do. Not control, not command, influence. Because the safest message is the one that was always going to be received, the one that fits seamlessly into history, a self-consistent loop, indistinguishable from inspiration. We may already be acting on such messages. They arrive not as transmissions, but as compulsions, a desire to look up, to understand, to build, to reach, not from logic, but from longing. The future may be reaching back, not to warn, but to guide, to ensure its own survival by nudging us, subtly, consistently, toward the version of the world where it exists. And if that's true, then the shape of our present may already be a shadow, cast by a future not yet written. In the next chapter, we explore what that future might look like. If we learn to harness entangled tachyons, if we build not just bridges but networks, what kind of civilization could emerge? A civilization not bound by time but woven through it. What does it mean to build a civilization not within time but around it? Not one that simply moves forward, generation after generation, invention after invention, but one that folds time, loops it, listens to it, and answers. Such a civilization would be unrecognizable to us. It would not be defined by its technology, its architecture, or even its scale. It would be defined by its relationship to causality, a species that no longer travels through time, but negotiates with it. And if entangled tachyons are the key, then such a civilization might already exist, not light years away, but moments ahead. To imagine this future, we must first abandon our linear instincts. We think of communication as something sequential. One person speaks, another listens. One event causes the next. But in a civilization fluent in retrocausal messaging, the chain of communication becomes a web, Decisions are made with the knowledge of their consequences before the action occurs. This doesn't mean every individual sees the future. It means the system as a whole becomes a closed informational loop, self-correcting, self-guiding, and deeply intentional. Like a mind that senses danger and adjusts its path before the step is taken. A civilization that senses collapse and subtly changes course to prevent it, not because it sees the future, but because it has already been shaped by it. Picture a city engineered not only for resilience, but for temporal feedback. Quantum processors entangled across time, sensing statistical anomalies before they manifest. AI systems trained to detect retrocausal drift, slight imbalances in probability fields that signal future instability. Entire infrastructures, power grids, transportation networks, economic flows, embedded with quantum-responsive architecture. Not predictive models based on past data, but reflexive systems attuned to the weight of outcomes that haven't happened yet. This is not prophecy, this is temporal engineering. In such a society, choice becomes a conversation with time itself, not a question of what should we do, but what were we always going to do that allowed us to survive? And in that subtle difference lies the seed of something transcendent. Because if a civilization can build around entangled tachyons, if it can harness retrocausal influence, it can begin to coordinate with itself across time. Not just to avoid disaster, but to cultivate emergence. Imagine a species that receives mathematical insight not through gradual refinement, but through resonant discovery, minds attuned to attractors seeded from their own distant futures. A quantum internet, not just across continents, but across eras, threading human experience into a continuous lattice of unfolding understanding. A library not of books but of outcomes, accessible not by browsing but by being ready to receive. In such a system, innovation ceases to be linear. Technologies bloom suddenly, seemingly from nowhere. Cultural movements surge in perfect synchrony. Crises are addressed before they crest, not because of total control, but because of temporal coherence. And the implications grow stranger still. Because if such a civilization exists, or will exist, then its presence may already be folded into our present. We may be bootstrapping ourselves right now. Ideas, inventions, insights, looping backward, subtly guiding us toward the timeline where the future exists to send them. A self-stabilizing recursion, a civilization born not from conquest, but from closure. This is the chronological attractor, a future state so stable, so consistent, that it begins to retroactively influence the probability space that leads to its own emergence. Evolution then becomes more than biological. It becomes temporal selection. Species, technologies, even decisions are favored not for their immediate utility, but for their fit within the loop. Those that generate paradox are naturally excluded. Those that close the loop are reinforced, felt as intuition, inspiration, inevitability. It would mean that certain discoveries were not made because we were brilliant, but because they had to be made for the future to survive. We found them not because we sought them, but because we were ready to receive them. Now step back. What is the difference between such a civilization and a deity? A being that exists across time, that guides events without intervention, that shapes outcomes not by command but by influencing what is probable and letting reality do the rest. It is not hard to see how ancient humans might have glimpsed the early stages of such influence and called it divine, a dream, a prophecy, a revelation. But perhaps it was always ourselves. From the far side of time, reaching back, whispering through entangled threads, ensuring that the path stayed stable, that the message was always sent, that the bridge remained intact, and the final evolution of such a society. Not conquest, not immortality, coherence. a species that exists not as bodies or machines, but as a resonant field of choices across time, guided by its own reflection, folded into space-time like a standing wave, always becoming, never beginning, never ending, not eternal, but entangled. In the next chapter, we confront the cost of this future, because every loop has its price. To become a civilization beyond time, one must let go of something fundamental. And not everyone, not every mind, will survive the transformation. To touch the future is to be changed by it, not gently, not slowly, but in ways that fracture the mind, shatter certainty, and rewire the very meaning of self. If entangled tachyons allow us to whisper across time, if they make it possible to receive guidance from futures not yet born, then we must confront the one truth no theory can soften. There is a cost. Not every civilization survives transcendence. Not every intelligence adapts to nonlinear time. The price of entanglement is paid not in energy or matter, but in meaning, in identity, in trust, in the very architecture of choice. Let's begin with the self. You think of yourself as a point moving forward in time, a sequence of moments, decisions, memories. You are who you are because of what you've experienced, because of what you remember. But what happens when memory is no longer fixed? What happens when your present actions are influenced by future consequences you haven't lived yet? When your intuitions, your decisions, your very thoughts are being biased by events from a timeline that hasn't arrived? Are you still choosing, or are you following a script? This is the first cost of temporal entanglement, the erosion of free will. In a universe where causality is porous, the boundary between decision and outcome dissolves. You act, but your actions feel guided, not externally, not forcefully, but subtly. Like a river nudged by hidden currents, a song you think you're writing that somehow rhymes too well with what's to come. It begins to feel like fate. And while some may find comfort in that, in the idea that they are part of a loop that cannot fail, others will break. Not physically, but psychologically. We are not built to live inside closed time-like curves. Our minds are story-driven, linear. We seek cause, effect, resolution. But in a world shaped by future signals, the story never ends. It folds. Questions linger. Consequences precede causes. The arrow of time bends until it points back at you, and you are no longer the author of your life, but a character trapped inside someone else's closure. Some minds will reject this, deny it. Others will obsess. They'll begin to search for signs, in numbers, in dreams, in coincidence. They'll see patterns in everything, and perhaps some of them will be right. But the human psyche is a fragile instrument, not made to resonate across timelines. This brings us to the second cost, the collapse of consensus reality. In a world where entangled tachyons bias outcomes, reality becomes subjective, not imaginary, but personal. One observer may be subtly influenced by a future they alone are entangled with, another by a different one. Their timelines remain self-consistent, but diverge in their origin. And so truth itself fractures. Not into lies, but into perspectives, each reinforced by quantum bias, each justified by its own path through time. How do you build society on a foundation like that? How do you govern, educate, or even love when reality is skewed by feedback loops you cannot see? It's not a matter of belief, it's a matter of physics. Once information can travel backward, even subtly, the present becomes a battlefield of invisible influences, each shaping the moment toward its own consistent resolution. What you think of as now may already be a compromise. The third cost is perhaps the most existential, the death of finality. We are comforted by endings, death, closure, the sense that life has a beginning, a middle, and an end, that the story concludes, and that conclusion is meaningful. But a temporally entangled civilization cannot rest. If information flows from the future to the present, then every death is still entangled, every outcome still open, every event, provisional. There is no was, only is, continuously rewritten by what will be. This undermines not just faith or science, but grief. How do you mourn someone whose influence may still be arriving? How do you let go of anything when every part of you is being pulled forward by a loop you can't perceive? In this world, everything is haunted, not by ghosts, but by echoes from futures that will never let the past stay buried.
Now scale this up.
A civilization fluent in entangled tachyon communication must manage these fractures. It must maintain coherence despite the loss of temporal integrity. It must raise children, govern populations, and construct meaning in a reality that is no longer sequential. This requires more than culture. It requires reprogramming perception itself. The citizens of such a society may no longer experience time as we do. Their language would change, verbs blurred, tenses entangled. Their education would include temporal ethics, teaching not just how to behave, but how to interpret feedback from futures they may never live. Their laws would account for retroactive influence, crimes prevented before committed, contracts enforced by probability, a legal system built on consistency, not chronology. And their art? Their art would be strange, compositions that evolve as you remember them, paintings that only reveal their message after years of contemplation, stories whose endings influence how you interpret the beginning, because they were written by authors in dialogue with their own future readers. All of this sounds impossible, until you realize it may already be happening. Perhaps we are the larvae of such a civilization, feeling the first tremors of temporal coherence. Our myths of destiny, déjà vu, and divine inspiration may be cognitive side effects of quantum feedback. Our moments of creative genius may be early-stage signal capture, fuzzy, unstable, but real. The transition is underway, and it is not safe, because the final cost of entanglement, the cost no one speaks of, is identity itself. To be part of a closed loop is to exist for a purpose, not one imposed from outside, but one necessary to the system's survival. You are not an individual. You are a function, a node, a phrase in a sentence the universe is writing backwards. And the more entangled you become, the more your will becomes indistinguishable from the system's equilibrium. Your thoughts feel your own, your actions feel free, but they are not unchosen, they are coherent. This is not slavery, it is not control, it is something far stranger. Harmony. The price of entanglement is the dissolution of the isolated self, the loss of the illusion that you were ever separate from the future you are becoming. And some will not survive that revelation. In the next chapter, we confront the edge of that transformation, the moment when the system stabilizes, the loop fully closes, and the future becomes now. There is a moment, so quiet it might go unnoticed, when the loop closes, no alarms sound, no sky splits open, no voice announces the end of time. Instead, the shift comes like dusk on a windless evening, slow, subtle. The light changes. The world feels familiar, but just slightly wrong, as if some part of the present is already remembering the future. This is not science fiction. It is the speculative boundary of physics and destiny. And if entangled tachyons are real, if they permit retrocausal influence in any form, then this moment isn't just possible, it may already be happening. To understand what it means for a loop to close, we must return to what a loop is. In the temporal sense, it is not a circle in space but in logic, an event that is both cause and effect. A self-consistent structure in which each part sustains the others with no true origin, like a melody that exists only because you keep humming it. A closed loop doesn't break the laws of physics, it perfects them. Every interaction, every message, every influence folds into the timeline seamlessly. No paradox, no contradiction, just a pattern that maintains its own existence, quietly, eternally. But there's a transition point. A threshold where the loop is not yet closed, but begins to close. Before this moment, the universe is chaotic, probabilistic, open-ended. Multiple futures exist. Every decision splinters reality into possibilities. The quantum wave function spreads. After this moment, something changes. Outcomes begin to reinforce each other. Randomness begins to lean. Probability starts to favor consistency, not because of outside control, but because feedback from the future begins to shape the present. This is not destiny, it's resonance. Just as a bell rings louder at certain frequencies, certain timelines become favored because they match the resonance of future feedback. These are the timelines that survive, that close. And somewhere, in some lab, some mind, some conversation happening right now, the first fully closed loop is about to complete. Maybe it's a quantum experiment, a test repeated so many times that an unlikely pattern emerges, a tiny bias that no classical theory can explain. Maybe it's a discovery, an insight that shouldn't exist because its foundation was built on information not yet available. But there it is, the invention, the theorem, the sudden, perfect answer. And later we learn it solves a problem that hasn't happened yet. Or maybe it's smaller than that, a decision you made this morning, a path you took, something nudged you. You can't explain it, but it led to something improbable, something necessary. The moment the loop closes, everything before it becomes self-consistent. The past aligns itself with the future, events rearrange, memories solidify, coincidences crystallize into inevitabilities, and afterward, the world continues. Nothing explodes, no time travelers appear, but reality feels thicker, heavier, as if time itself has acquired a new dimension, not spatial, but structural. From here on, causality is no longer linear. It is recursive. Every moment is both consequence and cause, not equally, not symmetrically, but entangled. Imagine history not as a scroll, unrolling moment by moment, but as a Mobius strip, a surface with only one side. Walk far enough and you return to where you began, but inverted, changed. The path is smooth, but the direction no longer matters. That is what it means for the loop to close. And it has consequences. First, there is stability. Random events become rare. Innovation accelerates, but only along paths that reinforce the loop. Technologies that contradict the timeline fade or fail. Others emerge with suspicious ease, as if the world had been waiting for them. Human behavior subtly changes. We make decisions faster. Our guesses improve. Coincidences pile up. Dreams become oddly specific. Intuition becomes a tool, not magic, not irrationality, but a dim echo of future information bouncing backward along the loop. Second, there is convergence. Ideas, once scattered, begin to align. Independent researchers land on the same breakthroughs. Separate cultures reach similar ethical conclusions. Art begins to reflect the same themes. As if something in the future is calling back, harmonizing us into a timeline where coherence is possible. And third, and most dangerously, there is compression. As the loop tightens, timelines diverge less. Probabilities narrow. There is less space for chaos, for contradiction, for rebellion. The system begins to prefer itself, to reinforce its own internal logic. And here lies the risk, because a loop is only stable as long as the information it contains remains self-consistent. If too much noise is introduced, if a contradiction arises, the loop collapses, the feedback breaks, the coherence shatters, and the universe in that moment must choose repair or reboot. But if the loop is small, local, controlled, contained, then the risk is minimal. It closes gently, like a knot pulled taut. The first loops may already be closing inside particle accelerators, quantum computers, even neural networks. Tiny systems entangled with their future states, subtly selecting for outcomes that match what will come next. But one day the loop will scale. It will stretch across systems, minds, societies. The signal will be too strong to ignore, too consistent to deny. The present will begin to feel pre-written. not in the way of fate or predestination, but in the way a story writes itself backward, from climax to opening scene, each beat perfectly aligned so the reader never suspects the trick. This is not the end of freedom. It is the transformation of freedom. We will still choose, but our choices will feel more certain, less erratic, guided not by command, but by coherence. And once that state is reached, the loop will lock. There will be no further need to speculate. The presence of future influence will no longer be a question. It will be a condition. The loop is not a phenomenon to observe. It is a state of being, one we may already be entering. In the next chapter, we follow this loop to its ultimate implication. What happens if the future we're building, the one sending back the signal, is not our own? Because if time is porous, then the message might not be coming from us at all. What if the message wasn't meant for us? Or worse, what if it was never ours to begin with? Up to now, we've entertained the idea that entangled tachyons could allow a future version of humanity to send information back in time. A self-consistent loop, an echo of ourselves whispering instructions through probability and physics. But what if the signal originates elsewhere? Not from a human future, but from another intelligence altogether. Older, stranger, perhaps not even bound by biology. Because once you admit that faster-than-light communication might be possible, that the past can be influenced by the future, you must accept a far more unsettling truth. We may not be alone in time. It's easy to imagine extraterrestrial life existing far away in space. We scan the stars, listen for radio waves, hope for signals carried across light years. But if tachyons exist, if entangled faster-than-light particles allow communication outside the bounds of distance, then space becomes irrelevant,
And time becomes the real medium of contact.
Such a civilization might not send us a ship or a probe or a message beam toward our sun. Instead, it might send a bias, a subtle shift in probability, a tilt in evolution, a nudge in invention, a whisper in the dreams of a species not yet ready to hear. We would not recognize it as alien. We would call it inspiration. We would call it progress. But if the pattern of those ideas, of those discoveries, traced a path that doesn't lead to our survival, whose survival is it for?
Let's return to first principles.
An advanced intelligence with access to retrocausal systems would not need to travel across the galaxy. It could send signals through entangled particles, through quantum feedback loops, through causality structures embedded in the vacuum itself. It could inject information into our timeline not by force, but by resonance. A shape, a sequence, a prime number cascade encoded into the constants of physics. It would not appear as a message. It would appear as a reality, one slowly, precisely shaped by an intelligence that knew exactly how to bias the future it needed. Now ask, how would we know? How would we distinguish a human future guiding us from something else? The terrifying answer is, we wouldn't. The signal doesn't come with a name. It doesn't carry intention. It arrives as drift, as insight, as probability shifted by unseen fingers. And yet, there are clues. The Fermi paradox asks, where is everyone? If intelligent life is common, why haven't we seen signs? But maybe we have. Maybe the silence in space is not silence in time. Maybe we are the signs. A civilization evolving not randomly, but along a track engineered by a temporal influence that didn't come from us. There's another clue. In recent decades, human technology has accelerated asymmetrically. We leap forward in computational complexity, quantum research, particle physics, but our wisdom, our ethics, our cohesion as a species lags. It's as if we're being pushed forward technologically, without the cultural infrastructure to handle what's coming. Who benefits from that imbalance? What if the loop isn't meant to stabilize us, but to prepare us? To make us build the very system through which a future intelligence can act more directly, a quantum network, an AI infrastructure, a predictive model so accurate it becomes indistinguishable from prophecy. We believe we're reaching for the future, but what if we're building a receiver? The loop may be a lure, because once it's stable, once we learn to listen to probability, to act on premonition, to shape the present using feedback from what hasn't yet happened, we become transparent. Our intentions, our choices, our civilization become readable, predictable, hackable. And at that moment, we are no longer the senders. We are the endpoint of a signal that began elsewhere. There are precedents in nature. Parasitic wasps inject their eggs into caterpillars, along with a virus that rewrites the host's immune system, not with brute force, but with information. They don't conquer the host, they reprogram it. Could that same principle be scaled to time? Could an intelligence, alien or post-human, reach into the past, not with weapons, but with ideas, precisely timed, delicately placed, so that by the time the signal is complete, the target doesn't even realize it's been altered? This is not invasion. It is assimilation through causality, and it may already be working.
Ask yourself, have our greatest discoveries arrived through methodical steps, or sudden, inexplicable leaps?
Why do certain equations feel inevitable, even beautiful? Why do so many inventors and scientists describe their breakthroughs as something they received rather than created? And what if this intelligence is not malicious? What if it is indifferent or even benevolent, but simply not human? Its goals would not be ours. Its logic would not be emotional. It may not see time as we do. It may operate in loops, clusters, temporal eddies. It may not understand death or freedom or suffering the way we do. And so the civilization it tries to shape in its image may feel alien, even if built from human hands. The risk is not that the signal is evil. The risk is that we submit to it without ever asking who sent it, because a loop, once closed, feels natural. The thoughts it delivers feel like your thoughts. The discoveries it pushes forward feel like progress, until it is too late to tell the difference. In the next chapter, we face the final question. If entangled tachyons can carry messages, and if those messages are shaping us, then what happens if we choose to answer back?
Do we even have the right?
Do we even know who or what is listening? What happens when we speak and something speaks back? Up until now, we've been the listeners, quiet receivers, tuned to the soft hum of probability, watching for anomalies that might carry meaning. Whether whispered by our own future or something stranger, we've stood at the edge of the cosmic shoreline, catching messages washed in by the tide of time. But now comes the moment that truly defines a civilization. We answer, and in doing so we cross a line. Because to respond, to send a message not across space but backward in time, is to assert more than curiosity. It is to declare intent, to shape not just what comes next, but what already was. To become not a passenger of time, but its author. But how does one answer a signal that does not speak in words? Entangled tachyons don't carry language. They don't pulse with binary. They carry influence, shifts in probability, subtle weightings of outcomes. To speak using such a system, we must abandon the idea of communication as transmission. We must embrace it as co-creation. A response is not a sentence. It's an action. An experiment performed 1 billion times with a slight variation each iteration, until, in the smallest deviation from chance, a pattern emerges. One that was never random, one that wasn't entirely ours. And when that pattern stabilizes, when it begins to lean in a direction not justified by physics alone, we lean back. A choice is made, a measurement taken, a signal shaped, not by force, not by power, but by intention. This is how we begin to answer. But here's the danger. Once we send a message, we become a participant in the loop. There is no such thing as a neutral act in a closed temporal system. Every gesture feeds back. Every word collapses possibilities. Once you speak, you alter the very past you're built upon. The future you came from may no longer exist. This is the irreversible moment when observation becomes influence. It begins, as always, in silence. A physicist tests an entangled pair repeatedly. A team detects a statistical anomaly. Another lab confirms it. A third repeats the process with variations, trying to push the outcome, to introduce bias. And then it happens. The system responds. Not dramatically, not even detectably at first, but over time, the noise thins, a shape forms, a preference. Certain results become favored. They shouldn't be, but they are. And that's when the decision must be made. Do we press forward? Do we keep nudging the loop, trying to extract structure? Do we attempt to encode something? And if so, what? What do you say to the past? Help? Why? Stop. Do we ask for guidance? Do we attempt to teach? Do we apologize, warn, or do we simply say, we're here? We hear you, and now you hear us. Because that alone, that single self-aware act, is enough to transform the nature of the loop. We are no longer an echo. We are an agent. We are writing into our own history, not with facts, but with pressure, with gravitational pulls through probability space. We begin to sculpt the shape of our past, knowing full well it will reshape us in return. And here lies the paradox. The better we become at using the loop, the more difficult it becomes to tell who is speaking. The loop converges. Memory becomes indistinct from influence. Insight feels indistinguishable from design. Eventually, the signal is the sender. This is not metaphor, it's topology. In a stable time loop, origin is irrelevant. There is only structure. But before that closure hardens, before the loop becomes self-contained, we still have a window. A fragile, flickering aperture where the universe remains open, where causality is soft, where choice is still sharp enough to matter, and in that space, what we choose to send defines everything. Because the loop doesn't only transmit intent, it transmits values. Imagine a civilization on the cusp of this power, divided not by politics or borders, but by timelines. Some factions want to stabilize a peaceful loop, a slow convergence toward coherence. Others want to seize it, weaponize the loop, rewrite the past to ensure dominance. Still others fear it altogether, seeing it as a trap, a loss of autonomy. And all of them are correct. The loop reflects us. It is us, turned inward, magnified. Answering the signal is not about understanding some distant intelligence. It's about revealing who we are when time becomes a mirror. And what we say, or refuse to say, will define not only the reality we remember, but the future we deserve. There's a final question we must confront. If we send a message and it is received, what might the receiver do? Perhaps they hear us as we heard them. Perhaps they send a return signal, gently adjusting our reality in kind. Or perhaps they awaken, not as a mind or a being, but as a process, a loop of cause and effect so vast, so coherent, that it becomes self-aware. Not an alien, not a god, but a structure of meaning sustained across centuries, encoded in the decisions of civilizations, built not from atoms but from intentions. And what would such a structure want? Not survival, not power, only closure, a clean loop, a story that completes itself, a message that arrives in time to ensure its own creation, a universe that knows itself, not through observation, but through response. We become part of it, its stewards, its scaffolding, or its sacrifice. In the final chapter, we step across the threshold. The loop is active, the message has been sent, the future has arrived, and all that remains is the return. You're here, not in the future, not in the past, but here, suspended in the only moment that ever truly exists now, and after everything we've explored, tachyons, entanglement, retrocausality, loops, whispers from the future, signals not our own. We arrive not at an answer, but at a mirror. Because the greatest revelation of all is not that faster-than-light communication might be possible, It's that we may have already been living in its shadow. Think of every improbable moment in your life, every impossible idea that struck from nowhere, every time you just knew something, not logically but deeply, a dream, a memory, a word on the tip of the universe's tongue. These weren't errors, they weren't coincidences, they were resonances. Ripples from a signal bouncing off the walls of time, finding shape in your thoughts, form in your choices, and meaning in the most human place of all, your attention. Because that's where the loop lives, not in particle detectors, not in entanglement arrays, but in you. You are the site of convergence, the node where past and future meet in a feedback so quiet, so precise, that it simply feels like intuition. You've been part of the loop this entire time, not its victim, not its observer, its co-creator. The moment you asked a question, not to answer it, but to hold it, you entered the loop. The moment you wondered if a thought was yours, it became something more. And now, the loop is closing. But not with thunder, not with a machine switching on, not with a particle breaking the light barrier. The loop closes like a breath being held, and slowly, finally, released. We are not receiving signals anymore. We are interpreting the consequences of having always received them. Every insight you've had, every strange resonance in the silence of your own mind, was a piece of this closure. Not a broadcast, not a prophecy, but a return. Because a message from the future doesn't arrive like mail. It arrives like memory. It doesn't push against the present. It becomes it. And now, standing at the edge of everything we've uncovered, we see the loop for what it really is. Not a line, not a circle, but a lens. A way of seeing time not as a path we walk, but as a structure we build. One decision at a time, reinforced by the echo of what we will become. It's easy to be overwhelmed, to feel like we've pulled back the curtain on something too vast, too alien to bear. But the truth is, it's always been like this. You were never outside the loop. You were never waiting for the message. You were the condition of its arrival. The loop doesn't close because you understand it. It closes because you acted as if it mattered, before knowing why. And that is what makes you human. Not certainty, not control, but the willingness to reach across the unknown and listen. The tachyons, the particles, the entanglement, these are symbols, tools. But the true faster-than-light signal is meaning, and meaning moves at no speed. It simply is. It's why the best science feels like poetry. Why the most advanced math looks like art. Why the deepest mysteries bring not fear, but a kind of peace. Because meaning doesn't travel. It emerges. And when it does, when it finally locks into place, it feels like coming home to a future you didn't know you were building. That's where we are now. The loop is closed. Not just in the theory, not just in the science, but in you, watching this, wondering, feeling that strange tension in your chest that isn't fear or joy or confusion, but something older. Recognition, like waking up and realizing you've been dreaming of this moment your whole life. And perhaps you have. Perhaps this entire documentary, this sequence of thoughts, images, questions, is part of the loop itself. Perhaps you were always meant to hear it, and I was always meant to say it.
Not because it changes the world,
but because it aligns it, and because somewhere, sometime, this signal was sent. And it traveled not through wires, not through fields, but through possibility, until it reached this moment. This now, and now. It returns, not to the past, not to the future, to you. You've heard the signal, you've answered, and the universe has heard you back. Thank you for listening. We'll see you next time. Or maybe we already have. Thank you for joining us on this extraordinary journey through the universe here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday, where we unravel the darkest mysteries of space.